Does Python require intimate knowledge of all classes in the inheritance chain? Python classes have no concept of public/private, so we are told to not touch something that starts with an underscore unless we created it. But does this not require complete knowledge of all classes from which we inherit, directly or indirectly? Witness. Expectedly, a type error is raised when none plus 1 is evaluated. So I have to know that underscore foo exists in the base class. To get around this, underscore foo can be used instead, which solves the problem by mangling the name. This seems to be, if not elegant, an acceptable solution. However, what happens if base inherits from a class, in a separate package, called sub? Now underscore foo in my sub overrides underscore foo in the grandparent sub. This implies that I have to know the entire inheritance chain, including all private objects each uses. The fact that Python is dynamically typed makes this even harder, since there are no declarations to search for. The worst part, however, is probably the fact base might inherit from object right now, but in some future release, it switches to inheriting from sub. Clearly, if I know sub is inherited from, I can rename my class, however annoying that is. But I can't see into the future. Is this not a case where a true private data type would prevent a problem? How, in Python, can I be sure that I'm not accidentally stepping on somebody's toes if those toes might spring into existence at some point in the future? Edit. I've apparently not made clear the primary question. I'm familiar with name mangling and the difference between a single and a double underscore. The question is, how do I deal with the fact that I might clash with classes whose existence I don't know of right now? If my parent class, which is in a package I did not write, happens to start inheriting from a class with the same name as my class, even name mangling won't help. Am I wrong in seeing this as a corner case that true private members would solve, but that Python has trouble with? Edit. As requested, the following is a full example. File parent.py. File sub.py. The grandparent's foo is called, but my underscore foo is used. Obviously you wouldn't write code like this yourself, but parent could easily be provided by a third party, the details of which could change at any time.
This implies that I have to know the entire inheritance chain. Yes, you should know the entire inheritance chain, or the docs for the object you are directly subclassing should tell you what you need to know. Subclassing is an advanced feature, and should be treated with care. A good example of docs specifying what should be overridden in a subclass is the threading class. This class represents an activity that is run in a separate thread of control. There are two ways to specify the activity: by passing the callable object to the constructor, or by overriding the run method in a subclass. No other methods, except for the constructor, should be overridden in a subclass. In other words, only override the underscore init underscore and run methods of this class.
Use private names instead of protected ones, starting with a double underscore. Will not conflict with underscore foo or underscore foo in base. This is because Python replaces the double underscore with a single underscore, and the name of the class. The following two lines are equivalent. In response to the edit, the chance that two classes in a class hierarchy not only have the same name, but that they are both using the same property name, and are both using the private mangled underscore form is so minuscule that it can be safely ignored in practice. I for one haven't heard of a single case so far. In theory, however, you are correct in that in order To formally verify correctness of a program, one must know the entire inheritance chain. Luckily, formal verification usually requires a fixed set of libraries in any case. This is in the spirit of the Zen of Python, which includes practicality beats purity.
Name mingling includes the class, so your base._foo and sub._foo will have different names. This was the entire reason for adding the name mingling feature to Python in the first place. One will be _base_foo, the other _sub_foo. Many people prefer to use composition, has a, instead of inheritance, is a, for some of these very reasons.
How often do you modify base classes and inheritance chains to introduce inheritance from a class with the same name as a subclass further down the chain? Less flippantly, yes, you have to know the code you are working with. You certainly have to know the public names being used, after all. Python being Python, discovering the public names in use by your ancestor classes takes pretty much the same effort as discovering the private ones. In years of Python programming, I have never found this to be much of an issue in practice. When you are naming instance variables, you should have a pretty good idea whether a name is generic enough that it's likely to be used in other contexts, and b, the class you're writing is likely to be involved in an inheritance hierarchy with other unknown classes. In such cases, you think a bit more carefully about the names you're using. Self.value isn't a great idea for an attribute name, and neither is something like adapter a great class name. In contrast, I have run into difficulties with the overuse of double underscore names a number of times. Python being Python, even private names tend to be accessed by code defined outside the class. You might think that it would always be bad practice to let an external function access private attributes, but what about things like getter and hasseter? The invocation of them can be in the class's own code, so the class is still controlling all access to the private attributes, but they still don't work without you doing the name mingling manually. If Python had actually enforced private variables, you couldn't use functions like those on them at all. These days I tend to reserve double underscore names for cases when I'm writing something very generic like a decorator, metaclass, or mixin that needs to add a secret attribute to the instances of the unknown classes it's applied to. And of course there's the standard dynamic language argument. The reality is that you have to test your code thoroughly to have much justification in making the claim my software works. Such testing will be very unlikely to miss the bugs caused by accidentally clashing names. If you are not doing that testing, then many more uncaught bugs will be introduced by other means than by accidental name clashes. In summation, the lack of private variables is just not that big a deal in idiomatic Python code in practice, and the addition of true private variables would cause more frequent problems in other ways.